Ax is equal to B. So if we need the values of x, y, z, then it is A inverse into B. To find A inverse, we have a formula 1 over determinant A into adjoint A. Now the same question can be asked with respect to the standard equation of an ellipse, that is x square by A square plus y square by B square is equal to 1. So if we replace sin x in the form of sine of minus x, then it is minus sin x. So therefore clearly this is an odd function. Everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. So we were discussing the model question paper of 2nd PUC prescribed by the Karnataka board. In this session, we'll take up part D and part E section. So let's look at the first question in part D. So question number 43 will be always from the chapter Relations and Function. Basically, this is a question on invertible function or bijective function. So we have here, let f from n to y be a function defined as f of x is equal to 4x plus 3, where y equals y belongs to n, y equals 4x plus 3 for some x belongs to n. Show that f is invertible, find the inverse of f. So here we can prove the invertible of a function by two methods. One is by the method of bijective function and the other is with the help of composition of function, that is f naught g equals identity function and g naught f equals identity function. So now I am proving this result with the help of bijective property. So now to show that the given function is bijective, first let us prove that it is 1, 1 and on to. To prove 1, 1, we'll consider f of x1 is equal to f of x2 for x1, x2 belongs to set n. Now here, f of x1 is nothing but 4x1 plus 3. F of x2 is nothing but 4x2 plus 3. So we can cancel 3 on both sides. Similarly, we can cancel 4 on both sides later. So we will get 4x1 is equal to 4x2. Here also, we'll get x1 is equal to x2. So for f of x1 is equal to f of x2, we are getting x1 is equal to x2. So which means f is 1, 1. Now let us see whether it is onto or not. Now let y belongs to set y such that f of x is equal to y. So which means 4x plus 3 is equal to y, 4x is equal to y minus 3, x is equal to y minus 3 divided by 4. So clearly from the given set, the condition of y is equal to 4x plus 3 for all x belongs to n. So here y is equal to 4x plus 3 if we take. So this set completely belongs to the domain n of natural number, that is x belongs to n. For all y belongs to y, we are getting x belongs to n. That means for each and every y, there is a pre-image in the domain. So therefore clearly f is onto. Now since f is 1, 1, f is onto, f is bijective and hence it is invertible. F is bijective and f is invertible. So writing the statements and the reason along with the conclusion also matters while proving this results. Now since f is invertible, clearly we can write f inverse of x in the form of x minus 3 divided by 4. So this is the inverse of the function. So other than these questions, they may ask you to prove the bijective of few functions. For instance, f of x is equal to 1 plus x square, f of x is equal to 3 minus 4x. So you are supposed to find the bijectivity of the given functions. Next question. Question number 44 will be on the operations of matrices. Here they have given us to prove the distributive law. There are few examples of proving the matrix equation is equal to null matrix and the transpose of a matrix, that is AB whole dash is equal to B dash A dash kind of. Other than this, they may ask you the questions on product and additions of matrices. Basically, the questions number 44 will be on the operation of matrices. Now here we have a question. A is given, B is given and C, all are matrix which is given. We need to calculate AC, BC, A plus B into C. Also verify A plus B into C is equal to AC plus BC. So here first calculate AC and BC. So A into C. So we know that A into C is nothing but first row into first column. So we have here 0 2 is 0, 6 into minus 2, minus 12, 7 into 3, 21. Next, second row into first column. There is only one column, so therefore the resultant matrix will be a column matrix itself. So here we have minus 6 into 2, 12, plus 0, plus 24. Next, the last row into the first column, 14, plus 16, plus 0. So this is AC. So if we add this, we will get here 9, 12, 30. Next, we'll take up BC. So first row into first column. So 0, minus 2, plus 3. Next, we have 2, plus 0, plus 6. Next, we have 2, minus 4, plus 0. So here we'll get matrix B as 1, 8, minus 2. Now let's take A plus B into C. First let us find what is A plus B. So add these two matrices. So we can add matrices only if they have the same order. So it's a 3 cross 3 matrix. It's a 3 cross 3 matrix. Now let's add the corresponding elements. So 0 plus 0, 0, 6 plus 1, 7, 7 plus 1, 8, minus 6 plus 1, minus 5, 0 plus 0. Next 8 plus 2, 10, 7 plus 1, 8, minus 8 plus 2, minus 6, 0 plus 0, 0. Now, let's take A plus B into C. A plus B into C. So, that means A plus B with a C. So, first let us multiply 0 into 2, 0, 7 into minus 2, minus 14, 8 into 3, 24. Next, we take minus 5 into 2, minus 10, 0. Next we have 10 into 3, 30. The last row with the column, so 16 plus 12 plus 0. Let's add this. So we have here 10, 30 minus 10, 20. Next we have 28. So now, we have here A plus B into C. Let's take it as equation 1. Now here we need AC plus BC. Let's add AC plus BC. AC plus BC. 9 plus 1, 10. Check. 12 plus 8, 20. Check. 30 minus 2, 28. So when we add AC plus BC, we are getting the value same as A plus B into C. So therefore, we can conclude that A plus B into C is equal to AC plus BC. Next question, a very important question. That means the question number 45 is fixed for the matrix method. That is the solving linear equations by matrix method using determinants. Now they have given system of linear equations here. 2x minus 3y plus 5z equals 11. 3x plus 2y minus 4z equals minus 5. X plus y minus 2z is equal to minus 3. Now let us write this matrix separating A, X and B. So now the coefficients of X, Y, Z are written in matrix A. So we have 2, minus 3, 5. Here 3, 2, minus 4, 1, 1, minus 2. Next, the variables are written in matrix X, X, Y, Z. And the constants are written in matrix B. So the constants are 11, minus 5, minus 3. So now here, when you multiply A into X, you will get B here. So A, X is equal to B. So if we need the values of X, Y, Z, then it is A inverse into B. To find A inverse, we have a formula 1 over determinant A into adjoint A. So here, once you have written the matrix, we need to find out the determinant A and adjoint A, and finally we'll take with product B. So then we'll find the values of x, y, z. So now first let us find determinant A. So now determinant A is equal to, I'm taking the first row, 2 into minus 2, minus 4, minus 1 into minus 4 is minus 4, which is plus 4. Next we have minus of minus 3. So 3 into minus 2, minus 6, 1 into minus 4, plus 4, plus 5. So we have 3 into 1, 3, minus 2. So here cancels, so this is 0. Minus 6 plus 4 is minus 2. Minus 2 into minus 3 is minus 6. So overall we have 3 signs here, so it is minus 6. Next we have 3 minus 2, 1 plus 5. So we are getting determinant A is equal to minus 1, which is not equal to 0. That means determinant A is non-singular, so therefore A inverse exists. So once we find the value of the determinant A, next we are supposed to find the adjoint of the given matrix. Adjoint of the given matrix is nothing but the transpose of the cofactors of a matrix. So now let's write the adjoint A. So before that, let us find what is the cofactors of each element. So now we have A11, A12, A13, A21, A22, A23. Next we have A31, A32, A33. So let's write all these in a vertical manner so that we can directly write adjoint A by writing the elements in terms of column wise. Now let's put the signs plus, minus, plus, minus, plus, minus, plus, minus, plus. Now let's write the cofactor of the first element. The first element is 2. So it's minor of the determinant, that is 2 into minus 2, 1 into minus 4. We already got here, so it is 0. So it is 0. Next we have for A12. So for A12, we have taken minus 6 plus 4, which is minus 2. So here we'll get minus 2, which becomes 2. Next we have A13. So for A13, it is 3 minus 2 we have got. So we'll get 1 here. So similarly, after calculating the remaining cofactors, we'll get A21 as minus 1, A22 as minus 9, A23 as minus 5, A31 as 2, A32 as 23, A33 as 13 element. So if I write all these elements in the form of column, so this is our adjoint A. So now the next thing is we need to find x is equal to A inverse into B. So x is x, y, z. A inverse is 1 over determinant A into adjoint A. So 1 divided by minus 1 into adjoint A. We have here 0, minus 1, 2, 2, minus 9, 23, 1, minus 5, 13. And matrix B is 11, minus 5, minus 3. So now if we take the product of these two matrices, and when we divide this by minus 1, we will get the value of x, y, z as 1, 2, 3. So therefore, x is equal to 1, y is equal to 2, and z is equal to 3 is the solution for the given system of linear equation by matrix method. Now, so the question number 45 will be from the chapter determinants. So basically on matrix method. Next, question number 46. So question number 46 will be from the chapter differentiation. So you will be getting the questions from second order derivatives. So here we have one question. If y is equal to 3 cos of log x plus 4 sin of log x, show that x square y2 plus x y1 plus y is equal to 0. So y1 means the first order derivative, that is dy by dx. y2 means the second order derivative, that is d square y by dx square. So now let us prove the result by taking the function y. So let's derive this first. Y becomes y1, 3 cos of log x. Cos of log x is a composite function. We need to apply the chain rule. So now 3 is a constant. Cos of log x is minus sin of log x. And log x is 1 by x. Next we have 4 sin of log x. So we get 4 cos of log x into 1 by x. Now to remove 1 by x on the right hand side, I'll multiply the whole equation by x. So then this equation becomes xy1 is equal to minus 3 sin log x plus 4 cos log x. Now again let us apply the derivatives. So here we have two functions. So first function into derivative of the second plus second function into derivative of the first. So y1 becomes y2 and derivative of x is 1. Again we have minus 3 as a constant. Sin of log x is cos of log x into 1 by x again. Next we have 4 as a constant. So cos of log x is minus sin of log x into 1 by x. Now to remove 1 by x again on the right hand side, I'll multiply x throughout the equation. X here becomes x square y2 plus x y1 is equal to, if I take minus is common here, we will get 3 cos of log x plus 4 sin of log x. So from the question, 3 cos of log x plus 4 sin of log x is nothing but y. So therefore this can be written as minus y. I'll shift minus y here. Then x square y2 plus x y1 plus y is equal to 0. Hence we have proved the given result. So this is how a statement or any prove that kind of questions will be asked from second order derivatives. Next question. Find the integral of 1 divided by x square minus a square with respect to x and hence evaluate integral of dx divided by x square minus 16. So this is a question from standard integrals. So we have 9 standard integrals. So in the examination, they may ask you the proof of any one of the standard integral and one simple problem related to the given integral. Now here, let us find the proof for 1 by x square minus a square. Now, 1 by x square minus a square, I'll write this in the form of 2a. I'll multiply 2a and divide by 2a. This x square minus a square, I'll write it in the form of x minus a, x plus a. Next, I'll write here this in the form of x plus a minus x minus a, which means I'm adding plus x and subtracting minus x and separating the terms in such a way that it is in the form of x plus a minus x minus a. So denominator, it is x minus a, x plus a. Next here, we have 1 divided by x square minus a square on the left hand side. So here it is 1 divided by 2a. Now I'll divide these two terms by the denominator. So x plus a cancel, we'll get 1 by x minus a minus 1 by x plus a. Next, I'll apply the integral on both sides with respect to dx. 1 by 2a is a constant. So I'm applying the integral with respect to dx. So here we have 1 divided by 2a. 1 by ax plus b form is log of ax plus b under the modulus. So here this becomes log modulus x minus a minus log modulus x plus a plus c. Now using the properties of log x minus log y can be written as log x by y. So therefore, integral of dx divided by x square minus a square is 1 divided by 2a log of x minus a divided by x plus a plus integration constant. So this is the proof of the given standard integral. Now they have asked a simple question. to find the integral of 1 by x square minus 16. Now here, using this property, here we have a square is nothing but 16. So a is equal to 4. Now if we apply the result, 1 by 2a means 1 by 2 into 4. So 1 by 8 log of x minus 4 divided by x plus 4 plus c. So this is the solution for the given integral. Next question. Find the area of the region bounded by the ellipse x square by 16 plus y square by 9 is equal to 1 using integration. So it's a very important question. So you can expect this question for your examination. From the chapter application of integrals, we have only two important derivation basically for 5 marks. That is the area bounded by the ellipse and area bounded by the circle. So here we have a question on the ellipse. So now let us take one ellipse here. So according to the question here, x square by 16, which is nothing but 4 square, plus y square by 9, 3 square is equal to 1. Now, I'll calculate the region only in the first quadrant, then I'll multiply the total area with 4. So then, let me consider this as AOB. The vertices of A is 4, 0 and B is 0, 3. So now, I need y here. So y is nothing but b by a root of a square minus x square. So which is 3 divided by 4 root of a square, which is nothing but 16 minus x square. Now I'll calculate the total area. So area is equal to 4 times 0 to 4 y dx. Now 4, 0 to 4, y is nothing but 3 by 4 root of 16 minus x square into dx. We know the standard integral, that is root of a square minus x square. So root of a square minus x square can be written as x by 2 root of a square minus a square plus a square by 2 sine inverse x by a. So if we apply here, then keeping 3 by 4 outside the integral, and applying the integral here, this is in the form of the standard integral. So this can be written as x by 2 root of a square minus x square, which means 16 minus x square plus a square by 2. A square is nothing but 16 by 2 sine inverse x by a, which is x by 4, and the limits are from 0 to 4. So clearly 4 cancels here, it is 3. Let's apply the limit as 4 here. So it is 4 by 2 root of 16 minus 4 square is 16 plus 8 here sine inverse of 4 by 4. So this is the upper limit minus the lower limit. If we put 0 here, 0 to x, this entire thing is 0, and if we put 0, sine inverse of 0 is again 0. So therefore the lower limit value is 0. Now here 16 minus 16 cancels, so this value turns to 0. So we are left with 3, 8, sine inverse of 4, 4 cancels, it is 1. So sine inverse of 1 is pi by 2. So 2 1s are 2 4s are 4, 3, 12 pi square units is the area of the given ellipse. Now the same question can be asked with respect to the standard equation of an ellipse, that is x square by a square plus y square by b square is equal to 1, or the standard equation of a circle, x square plus y square is equal to a square. Next question, we have one questions from the linear differential equation, that is to find the general solution of the given differential equation. So question number 49 is from the chapter differential equation. So once any differential equation is given, we need to see whether it is in the standard form of dy by dx or dx by dy. Now here, since the question is given in the form of dy by dx, we have x here. So to remove x, I'll divide the whole equation by x. Then I'll get dy by dx plus 2 by x into y, x into log x. If you compare this equation with the standard equation of dy by dx plus py is equal to q, clearly we can see p is equal to 2 by x and q is equal to x log x. So now by taking the solutions here, integral factor is equal to e to the power integral of p dx. So if we take this, it is integral of 2 by x, I'll keep 2 outside, 1 by x dx. So which is e 2 log x or e log x square. E power log can be taken out. So the value is x square. Now we can write the solution in the form of y into integral factor is equal to q into integral factor dx plus c. So here we'll get x square y is equal to q is x log x, integral factor is x square dx plus c. So we can write this integral as log x into x cube dx plus c. So now here we have two functions, log and x cube. So here we can apply the integration by parts. So first function, integral of the second, x power 4 by 4 minus derivative of log 1 by x, again integral of the second, x power 4 by 4 dx plus c. So here we have x power 4 by 4 into log x minus again x cube becomes x power 4 by 4. So here it is 1 by 16 and x power 4 plus c. On the left hand side we have x square by y. So this is the general solution of the given differential equation. Now the last question in the section part D is from the chapter 3-dimensional geometry. So here you can expect the derivation of the vector and Cartesian form of an equation of line, which is for 5-mark question. So now derive the equation of a line in space through a given point and parallel to a vector both in the vector and Cartesian form. This is very, very important question from the chapter 3-dimensional geometry and the part D section. So now here let us consider XYZ axis and let me consider a line L passing through a point A. So now this is O. Let OA be the position vector. I'll consider this as vector A. Now let this line be passing through point A and parallel to vector B. So this is vector B. Let me consider any point P on the line, any arbitrary point on the line, and let the position vector of this point from the origin be R. So vector OP is equal to R. So now from the figure here, since the line is parallel to vector B, vector AP, so this point lies on the line. So if we take this line segment AP in the vector form, AP is also parallel to vector B. So from the figure we can write vector AP is equal to some lambda into vector B, where lambda is any scalar. Using the position vector, vector AP can be written as OP minus OA is equal to lambda B. OP is nothing but R minus A is equal to lambda B. Hence, vector R is equal to vector A plus lambda B. So this is the vector form of an equation of line. Let me consider this as equation 1. Now, let us write the vector form in the Cartesian form. So let us take point A as point x1, y1, z1 and point P as xyz. Let the direction ratios of vector B be A, B, C. Then vector R is xi plus yj plus zk. And vector A is equal to x1i plus y1j plus z1k. And vector B is equal to AI plus BJ plus CK. Now substituting the value of R, A, B in equation 1 and equating the coefficients of I, J, K, we will get x is equal to x1 plus lambda A, y is equal to y1 plus lambda B, z is equal to z1 plus lambda c, which can be written as x minus x1 by a is equal to lambda, y minus y1 by b is equal to lambda, z minus z1 by c is equal to lambda. Now all these equal to the parameter lambda. So eliminating lambda, so we can write this equation in the form x minus x1 by a equals y minus y1 by b equals z minus z1 by c. So this is the equation of a line in Cartesian form. The last section in the question paper is part E for 6 marks and 4 mark question. Now we have here a 6 mark question. So question number 51 is from the chapter integration. Basically, they'll ask you the question on the properties of integration and one simple problem on the given property, or they may ask you a question from linear programming problem, that is solving system of linear equation with the help of graphical method. Now let's see the solutions for these questions. Question number 51, prove that integral minus a to a f of x dx is equal to 2 times 0 to a f of x dx if f of x is an even function and 0 if f of x is an odd function, and hence evaluate integral from minus pi by 2 to plus pi by 2 sine to the power 7x dx. Now for the proof of this integral, we know that integral from minus a to a f of x dx can be written as integral minus a to 0 f of x dx plus integral 0 to a f of x dx. Now let me consider the first integral here, minus a to 0 f of x dx. Here put x is equal to minus t, then dx is equal to minus dt. So when you take x is equal to here, if you take x is equal to minus a, then t is equal to a, and if you take x is equal to 0, t is equal to 0. So therefore here the limits changes to a to 0 f of minus t minus dt. Now since we have minus inside the integral, we can change the limits to, now here since we have negative inside the integral, we can make it positive by changing the limits a to 0 to 0 to a. Now let us replace back the value of x instead of t. Now let us replace back the variable. So here instead of minus t, I can write it as f of minus x, and dt can be written as dx. So now the integral minus a to 0 f of x dx is in the form of 0 to a f of minus x dx. So now let's take this as an equation star. Now depending upon f of minus x is even or f of x is odd, so the integral minus a to a f of x dx is now in the form of 0 to a f of minus x dx plus 0 to a f of x dx. Now the first case, if f is even, then f of minus x is same as f of x. So if we write f of x here instead of f of minus x, then we have 0 to a f of x dx, 0 to a f of x dx 2 times. Therefore here minus a to a f of x dx is 2 times 0 to a f of x dx. Now case 2, f is odd. So f is odd means f of minus x is minus f of x. So if we replace f of minus x by minus f of x in this integral, 0 to a dx with minus f of x cancels with 0 to a with plus f of x. So therefore here integral minus a to a f of x dx becomes 0. So hence proved. Now they have given the integral minus pi by 2 to plus pi by 2 sine to the power 7x dx. So clearly this is in the form of minus a to a sine to the power 7x dx. So if we replace sine x in the form of sine of minus x, then it is minus sine x. So therefore clearly this is an odd function. So for an odd function of this type, the value is 0. So with the help of property, we can write the value of an integral as 0. Now, let us find the solution for the graphical method of solving system of linear equation. So, we need to find out the minimum value of the function z is equal to 200x plus 500y with the equations x plus 2y greater than or equal to 10, 3x plus 4y less than or equal to 24. Now, let us find the solution for these two equations. The first equation is x plus 2y greater than or equal to 10. Second equation is 3x plus 4y less than or equal to 24. So now if we find the solution in the form of x and y, if x is 0, y is 5. If y is 0, x is 10. So the point is 0, 5 and 10, 0. Now here if we take the x and y, if x is 0, y is 6. If y is 0, x is 8. So now the points are 0, 6 and 8, 0. So clearly if we plot in x and y axis, so taking 1, 2, 3, 4, 5, 6, 7, 8, 9 and here I'll take this in the form of 2, 4, 6, 8, 10. So if we plot this with the graph, so the first point is 0, 5 and the second point is 10, 0. So we'll get a line. So write the equation of this line, that is x plus 2y greater than or equal to 10. So greater than or equal to 10 means obviously the solution region of this line will be above the line. Now let's take 3x plus 4y less than or equal to 24, that is 0, 6 and 8, 0. So we'll get the equation of a line, a straight line. So here the equation of the line is 3x plus 4y less than or equal to 24. Now let's decide the feasible region for the given equation. Now for this line, 3x plus 4y less than or equal to 24 means obviously it is below the region. Or we can also verify this by taking x and y 0. So here 0 is greater than or equal to 10. So here it's a false statement. That means the solution region of this line should be the region which does not contain 0. So that is why the region above the line falls as feasible region for the given equation. Now for this equation, if you put x and y as 0, we get 0 less than or equal to 24, which is a true statement. That's why the region which contains 0 will fall as the solution for the given line. Hence for the given line, the region below the line is the solution. So when you observe the situations of these line, the region here will satisfy the condition of the feasible region. Once you find out the feasible region, just mark the corner points and write the coordinates of the given point. Now for the given line, the corner points will be at 0, 5, B will be 4, 3 and C will be 0, 6. So if you plot this cleanly in terms of graph sheet, so this point is actually 4, 3. Now let's find the solution of Z using these corner points. Now my linear function is 200x plus 500y. Let's substitute these values. Here x is 0, so the value is 2500. So it is 800 plus 1500, which is equal to 2300. And here it is 3000. So clearly we need to find out the minimum value of the objective function. So here 2300 is the minimum value. So therefore Z has minimum value of 2300 at the corner point 4, 3. So this is how we find the solution of the given equation with graphical method. Now the last question in the question paper is for 4 marks category. So here one question will be from the chapter determinants and the other question will be from the chapter continuity. So determinants, they will ask you the questions on the matrix equation and finding A inverse using this equation itself. And in the chapter continuity, they'll ask you the condition by giving the given function is continuous and hence find the value of an unknown variable. It may be a, b, k, anything. So using the property of continuity, we are going to find out the value of k. Now let's find the solution for these two questions. So first, show that the matrix A 2, 3, 1, 2 satisfy the equation A square minus 4A plus I equals O, where I is 2 cross 2 identity matrix and O is 2 cross 2 0 matrix. Using this equation, find A inverse. Now let us first verify and show that A square minus 4A plus I is equal to 0. Now A square is equal to 2, 3, 1, 2. 2, 3, 1, 2. So let's find A square. First row into first column, 2 2s are 4, 3 1s are 3. So 4 plus 3, 7. First row, second column, 2 3s are 6 plus 3 2s are 6, 12. 1 2s are 2, 2 1s are 2, 4. 1 3s are 3 plus 2 2s are 4, 7. Next, we will take the matrix 4A. So 4A is nothing but we are multiplying 4 to the given matrix. So 4 2s are 8, 4 3s are 12, 4 1s are 4 and we have 4 2s are 8. Let's take the equation A square minus 4A plus I equals 0. Let's take the equation A square minus 4A plus I. So A square is 7, 12, 4, 7. 4A is 8, 12, 4, 8 plus I is 1, 0, 0, 1. So 7 minus 8 minus 1 plus 1, 0. 12 minus 12 plus 0, 0. 4 minus 4 plus 0, 0. 7 minus 8 plus 1, 0. So clearly, it's a null matrix. Now let's consider this equation. A square minus 4A plus I equals O. Now using this equation only, we need to multiply A inverse on both sides to find A inverse. Now here, pre-multiply A inverse on both sides. I'll write A square as A into A. I'll keep constant outside and I'll multiply A inverse into A plus A inverse into I, A inverse into O. Using the associative property, we have A inverse into A, which can be written as I into A minus 4 into I plus A inverse equals O. Now, this is A minus 4I plus A inverse equals O, or 0 also we can consider. So A inverse is 4I minus A. So 4I is nothing but 4, 0, 0, 4 and matrix A is 2, 3, 1, 2. So therefore clearly A inverse is equal to 4 minus 2, 2, 0 minus 3, minus 3, 0 minus 1, minus 1, 4 minus 2, 2. So this is the inverse of the given matrix. Next, find the value of k so that the function f of x is equal to k cos x divided by pi minus 2x if x is not equal to pi by 2 and 3 if x is equal to pi by 2. Now the given function is in this form and they have clearly said it is continuous at pi by 2, which means limit x tends to pi by 2, f of x will be equal to f of pi by 2. So clearly we have limit x tends to pi by 2, f of x when it is not equal to pi by 2 is k cos x divided by pi minus 2x. And when it is equal to pi by 2, the value is equal to 3. So here I'll take x is equal to pi by 2 minus h. So this implies as x tends to pi by 2, h tends to 0. So now I'll change the limits here. So limit h tends to 0, k into cos pi by 2 minus h whole divided by pi minus 2 into pi by 2 minus h. So here we have 3. So cos pi by 2 minus h can be written as sin h. 2 into pi by 2 becomes pi, minus into minus plus 2h. So limit as h tends to 0, k sin h divided by pi minus pi plus 2h is equal to 3. So pi and pi get cancels here. So then it will be in the form of k sine h divided by 2h as limit h tends to 0. Now taking k by 2 outside, applying the limit sine h by h with the limit h tends to 0, and on the right hand side we have 3. So we get limit h tends to 0 sine h by h as 1, because it's the standard limit of the form limit x tends to 0 sine x divided by x is equal to 1, where x is in radians. Now k is equal to 6. So this is the value of k. So clearly we have found the solutions of all questions. We have cleared the solutions of the entire model question paper of 2023-24. So hope you clearly understood how to plan for the given upcoming exam. So I hope solving this model question paper helped you to plan for your upcoming examination. So good luck for your examination. I'll meet you in the next session. Until then, keep watching, keep learning, keep exploring. Thank you.